maximum depth of a binary tree 104. The problem statement is like, given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of the nodes along the longest path from the root node down to the farthest leaf node. So here in example given, if you can see, 3 is the root and 9, 20, 15 and 7 are the nodes, and leaf nodes are 9 and then 15 and 7. But we have to find the maximum depth. Okay, so maximum depth is kind of from root node to the longest leaf node. That is the number of the nodes, like 3, then 20, then 15, or to the 7. So maximum depth would be 3 here. Yeah, got it. So yeah, let's see constants. Okay, no dot value is less than or equal to 100 minus 100. Okay, it's good. So we can solve it using, I think, BFS. So let's see for BFS what we have to do. We have to traverse from root node is level by level, and we have to reach to the longest level. Okay, so longest level would be 1, 2, 3. So 3 would be the maximum depth of the tree. So I'm using BFS here. I think this problem can be solved using DFS also, but let's try with BFS first. Okay, so what I'm thinking of is to take a max depth helper, which I will pass here. It will simply do nothing more than returning the root. Okay. So simple BFS approach is to take a queue of tree node. Q is equal to new. Let's take it LinkedIn. I'm sorry, not LinkedIn, but linked list. Implementation of the queue. We need a depth variable. Suppose I start from 1. Actually, we can start from level 0. I am considering this to be level 3. And we will add +1 to the level. Okay, while returning, because we are starting from 1. Now what we need to see, if let's check for the edge case. Edge case, if root is equal to null, we simply return 0, right? Now if root is not null, what we have to do, we have to offer this to the queue. So basically we are going with the Java language. Queue.offer is inbuilt method, and we can enqueue the root here. Now what we need to do, once we have offered this, we can start the general while loop, which says like, if queue is not empty, then what we need to do, we need to start the BFS, like level order traversal. Okay, so and suppose I want to calculate every time I need to update the level. Okay, every time while entering this level we need to update the level. So what we can do, 3 is level 0. Okay, so we need to check for the leaf nodes, like if root. Let me take first or tree node current equal to new not new, let's call from the this, because we want to call, we want to pick the first element from the queue and delete it. Okay. So we get the root node from here into the current node. Now what we need to do is, let's start the traversal, and I'm taking the size actually here, n is equal to q dot size. Okay, and we will iterate till I is less than n, and then I plus plus. What is our scenario? Our scenario is reached to the maximum level. Okay, so maximum level we need to reach. So what we have to do, if current dot left not equal to null, then we need to push it into the queue. Queue dot offer current dot left. Okay. If current dot right is not equal to null, what we have to do, queue dot offer current dot right. Good. Yeah, so we have offered both of this, and what we need to do, if both we have done this, we have offered it to the queue. Every time when we have offered this, what we have to do after exiting the for loop, what we have to do, we have to depth plus plus, right? Inside the while loop, we need to increase the depth plus plus, and while return depth plus 1, right? Let's see. Somewhere we are wrong. Case 1 is 2, but this is not working. I am returning this step plus plus. Let me see where I have made the mistake. Q, first of all, 3 would come here. This root node entire size will be 1. If current dot left is not null, which is 9, it will enqueue to the queue. Okay, so enqueue will be queue 3, and then 9 and 20 will be enqueued. Okay, after that it will exit the for loop for one time, and then depth would be increased. Okay, so depth will be 1. Now it will look into the queue. Queue is not empty because 9 and 20 are there in the queue. Now it will call 9 here, and queue dot size is 2 right now, so it will call 9. So 2 times this loop would go. Current dot left is not equal to null. Here it is null, so no new node would be entered here. Okay, and then same for 20. Sorry, right of the 9, it will also not be there. Okay, So you go for 20. For 20 it would add 15 since its left is this, and then 7 will be added. Okay, cool. Then we will increase the depth first. Now actually I think I am falling before the node. Okay.